Section 8.3, types of reactions. Generally, there are 5 types of inorganic reactions. We'll learn about some very specific ones like the acid-base reactions and what are called redox reactions. So we'll talk about those in this course, and then we'll also get into them more in the in AP. So what we're going to focus on, this is RXN, I'm trying to write over here. What we're going to focus on are just the 5 basic types. So the first type is what's called a combination or synthesis reaction, and the key to this is you're always going to form one product, okay? So that'll be the sign. Anytime you see a reaction where only one product is formed, that's going to be a synthesis or a combination reaction. Now, you are not expected to be able to predict these types of reactions, okay? Some you have to predict, not these, all right? Decomposition reactions. So these are reactions that break down. For these, you're always going to start out with one reactant. So again, on these, you are not expected to predict the products, but you are expected to be able to look at it and say, oh, that's a decomposition reaction, okay? So it starts out with one product, breaks into two or more, or starts out with one reactant, breaks into 2 or more products, okay? Now, the next 3, you are expected to be able to predict. So the first one is the single replacement reaction. And for this, you usually have a single element off by itself, and then it reacts with typically an ionic compound. All right, so let's look at an example here. Here's zinc all by itself. It's reacting with hydrochloric acid, HCl, and that's ionic. And so what happens is the zinc, in this case, comes and takes the place of the hydrogen. So then the hydrogen goes off by itself, and then we end up with zinc chloride. Okay, now let's look at another one, and I'll just sort of jot this one down here. We're going to say copper, solid, plus silver nitrate, AgNO3. And that's aqueous. Now, for this, remember the copper, it's a metal. So the metal, which is right here, is going to replace the other metal. And then that metal is going to go off by itself. So the copper is going to go with the nitrate. It's going to form copper 1 nitrate. How do I know? Well, I just know. It's never something really that you have to figure out. You'll always sort of be told what ion it's going to form, if it forms more than one ion. We'll do one next. That's not that way. All right. So there's copper 1 nitrate, and then we're left with silver. And now when it's by itself, it's going to be a solid. So there's a single replacement reaction. Now let me show you one where you do have to know the charge. So let's take magnesium, and let's put that into some nitric acid, HNO3. Okay, again, here's the metal. Hydrogen is the cation, so we're going to say it's the metal, even though it's not actually a metal. So it's going to come and replace that hydrogen, and then that hydrogen is going to go off by itself. So this is where you have to be careful, because a lot of kids will write MgNO3, but of course that's wrong. Why is it wrong? Magnesium is positive 2, nitrate's negative 1. Does that equal 0? Nope, it does not. So you have to remember the charges. They combine according to the charges. So this one, magnesium is positive 2, nitrate's negative 1, so I need 2 nitrates. And that's going to be aqueous, and we can figure out that it's aqueous by looking at a solubility table, which is something we'll look at later on. And then it gives off just hydrogen by itself. Now hydrogen is one of the magnificent 7, so it's a diatomic molecule, so it's always going to form H2, and in this case it's going to be a gas. Okay, so there's a single replacement reaction. Now a double replacement reaction, very similar, except we have 2 ionic compounds that are reacting. So take a look here. Here's sodium sulfate. All right, that's going to react with barium chloride. Now what's going to happen is the sodium is going to go with the chloride, and the barium is going to go with the sulfate. I almost drew it to the sulfate. The barium is going to go with the sulfate. There you go. Okay. So we end up with barium sulfate and sodium chloride. Okay. Now let me show you another one of these. Let's do a good one. Let's do magnesium phosphate, so Mg3PO4 2, we'll say that's aqueous, is going to react with, let's go with aluminum sulfate. So Al2SO4 3. I guess that one's right. Right? So what are we going to get? Well, the magnesium is going to get with the sulfate, and the aluminum is going to get with the phosphate. So we're going to end up with magnesium sulfate, which is MgSO4, because this is plus 2 and this is minus 2, plus aluminum phosphate, which is just going to be AlPO4. And those are both going to be aqueous. Now aluminum is plus 3, phosphate's minus 3. So that's a double replacement reaction. And the last one, and kids struggle with this every year, but the last one is what's called a combustion reaction. And for us, it's only going to be a hydrocarbon. A hydrocarbon is a CXHY, where X and Y can be any number, almost any number. And it's just carbons and hydrogen. That's what a hydrocarbon is. But we're going to combust it. We're going to burn it. And so that's really a combination with oxygen. 100% of the time, these will produce carbon dioxide and water. I'll give you an example here. Here's benzene, C6H6, with oxygen. What are the products going to be? Well, that's a hydrocarbon combining with an oxygen. Products are going to be carbon dioxide and water. Okay? Water gas, carbon dioxide gas. And then, of course, you have to balance it. But that's a combustion reaction. You can have some reactions that are a combination of these 5 types, but we generally stick to just one type of reaction. So you have to be able to predict the products of single replacement. So predict the products. Double replacement, you've got to be able to predict the products. And combustion. Those are the 3 that you have to be able to predict the products. Everything else you just have to be able to recognize. You better recognize.